So similar problem we are going to continue for the performance characteristics of an antenna. So the given problem is an antenna having source with radiation intensity U is equal to 6 cos theta has to be designed for unidirectional application. You are asked to find the directivity, right? So similar to the previous problem. So you know the formula for directivity, that is equal to 4 pi U mass divided by power radiation, and you know the formula for power radiation also with respect to theta and phi. So here this is a general, so in previous problem we have taken the limit for theta and pi is equal to 0 to pi. So since it is given in the problem, we have taken the limitation as 0 to pi for both theta as well as phi. But here the given antenna is used for unidirectional application. So the theta limits for unidirectional means 0 to pi by 2. So by substituting the integral value and substituting the power density form value given 6 cos theta, you can able to evaluate the integration. So here instead of this u of theta comma phi, you can substitute 6 cos theta. So and then evaluate the integration, you will be getting the answer is 6 pi. So right, so this is the power radiation. Then you can substitute in the formula of directivity, that is 4 pi u mass divided by p rad. So then you can calculate, you can now get the answer for directivity is equal to 4 after simplification. Then if you are asked to find the value of beam width, right? So this is a formula for beam width, that is equal to 4 pi by d. So d is the directivity, just now we have calculated as 4. So the beam width is equal to pi radiation, and here by using that beam width you can able to calculate HPBW, that is nothing but half power beam width, that is equal to 1 by 2 of this beam width, so it is equal to pi by 2. Then next problem, so it is given as the consider two similar dipole having the length of the 3 meter, having the length of 3 meter, used as the transmitting and receiving antenna. Find the power received by receiving antenna if it is placed at a distance of 10 meter, at a distance of 10 meter from a transmitting antenna which is radiating 50 watt average power at 1 gigahertz. So these are the given parameters. So what you are asked to find, you are asked to find the power received by receiving antenna, that is the received power you are asked to find. So according to the Friis formula, you know the formula for the radiation power, PR is equal to PT GT GR into lambda by 4 by D the whole square, where PT is the transmitting power, GT is the transmitting gain, GR is the receiving gain, and D is the separation between the transmitting and receiving antenna. Lambda is the wavelength which can be calculated by using the formula C by F, right? So by substituting all the given values, right? So PT is given 50 watt and GT is GT is given us the 1 point, GT is given us it is given no 1.5, yes, it is given us 1.5, and the frequency it is given us 1 gigahertz, and the distance is 10 meter it is given, right? So by substituting all the values, you can able to calculate the received power, which is 192.3 microwatt. Then next problem, two spacecraft are separated by 300 meters, right? So the distance of separation 300 meter, each has antenna with GD max is equal to 20. So the antenna gain is 20, operating at 2 gigahertz. So operating frequency is 20. If the receiver on spacecraft A requires 20 dB, right? So requires 20 dB. That means the transmitting power should be 20 dB. Power over 1 picowatt. Power over 1 picowatt. What transmitter power is required on the spacecraft B to achieve this signal level, right? So here the given parameter F is given, GD max is equal to D given, and D is given, that is 300 kilometers, and the received power is given over the power of 1 picowatt, right? So first we are calculating the lambda by using the formula C by F. Then the received power A needs 20 dB over 1 picowatt, right? So 20 dB is the power out of 1 picowatt. So what will be the received power? So this is PR. So if you substitute 20 and here, right? So 20 divided PR by 1 into 10 power minus 12, it is equal to 20 divided by 10. Then if you take the anti-log, you will be getting the answer for the PR. So PR is equal to 1 into 10 power minus 10 watt. Then you know the formula for received power according to the Freese formula, that is equal to PT GT GR into lambda by 4 pi the D the whole square. So if you substitute all the given values, so GT GR, so both are 200. So here here each has the antenna with the given. So both the transmitting and receiving antenna having the gain of 200. So which is substituted here, and PR just may we calculated substituted here. 4 pi D is given as 300 into 10 power 3, and lambda we can able to calculate by using C by F, where F is equal to 2 gigahertz, right? So if you substitute all those things, and you will be getting the answer for the PT is equal to 157.91 watt, right? The next problem, 2 half wave vertical dipole antenna with a gain of 1.64, right? So two antennas with a gain of 1.64 are horizontally separated by a distance of 100 km, horizontally separated by a distance of 100 km to form a transmitter receiver link. The transmitter feeds this antenna with 10 watt at 100 megahertz, right? So 10 watt at 100 megahertz, calculate the power received by the other antenna. So you have to use the Freese formula to calculate the received power. So this is the formula. So here both the antennas having 1.64, it is given, and G is given, right? G is given, that is 100 megahertz, and D is also given, that is 100 kilometer, and PT is given, that is 100 watts. If you substitute all those things, you will be getting the received power for the antenna is 6.4 microwatt.